We continue. The initial velocity is 1 meter per second. Acceleration is 3 meters per second squared. And our displacement is 4 meters. How fast are we going after having traveled for 4 meters? The final velocity squared is equal to our initial velocity squared plus 2 times our acceleration times our displacement. That is equal to 1 plus 24 for a total of 25 meters squared per second squared. We now take the square root, so VF, final velocity, is 5 meters per second. At this point, we will solve one more problem. Please attempt this problem on your own. Pause the video. After you've attempted the problem, hit play and follow along with the solution. The car is traveling at 24 meters per second when the driver applies the brakes. This causes a uniform acceleration of -3 meters per second squared. How long does it take the car to stop? We need to write down our knowns. For example, our initial velocity is 24 meters per second. Our final velocity is actually known, even though it is not explicitly stated in the problem. If we're coming to a stop, our final velocity must be 0. Our acceleration is -3 meters per second squared. We are solving for the time. Sometimes that's indicated by time equals question mark. And we need an equation. It's got to be an equation that has these other 3 variables and has t. And that would be VF equals VI plus AT. It is a good practice to solve for the variable that we need instead of plugging in the numbers first and then solving. And so we solve for t before plugging in numbers. The time is final velocity of 0 minus initial velocity of 24 meters per second divided by an acceleration of -3 meters per second squared, and that comes to 8 seconds. How far does the car travel as it comes to a stop? We are solving for x. VI is still the 24 meters per second, VF is still 0, and we had the same acceleration. An equation that we can use is this one. X equals initial velocity times our time. Sorry, that would be 8 seconds. It took us 8 seconds to stop. That's what we figured out in the first problem. Plus 1/2. Our acceleration is a -3 meters per second squared. And then we have time squared. 24 times 8 is 192 meters. The last term will be subtracted. 1/2 times a -3 times a 64 is -96. This comes to 96 meters. How far does the car travel during the first 4 seconds of braking? You might be tempted to think that it's half of 96 meters, but that's not true. During the first 4 seconds, the overall speed of the car is relatively fast. For the last 4 seconds, the speed of the car is relatively slow. More distance is covered in the first 4 seconds than in the last 4 seconds, and we will see that. We use the same equation as before, x equals VIT plus 1/2 AT squared, and this time we just plug in 4 seconds for time. This simplifies to 96 meters minus 24 meters, which is 72 meters. The car travels 72 meters in the first 4 seconds and an additional 24 meters in the last 4 seconds.